In this video, I'm going to talk about how to factor higher degree polynomials. We've talked about how to factor polynomials that had the highest degree x squared. We talked about that a lot. And now we're going to talk about how to factor when we have higher powers like x cubed and x to the fourth power. Because it's really important that we know how to factor those things, since we need factored form in order to be able to graph those higher degree polynomials. That's the form that's going to show us our x-intercepts, which are the most important points on our graph for a higher degree polynomial. First thing I want to do is I want to look for a pattern between these three foiling examples. I'm going to start with the one on the left. So I'm going to multiply x minus 3 times x squared plus 3x plus 9. Since I have 2 terms by 3 terms, just so I don't make a mistake, so I know that I'm including everything and I'm not forgetting anything, I like to use the area box, and I suggest that you use it too so you don't forget anything. For this, I'm going to have a 2 by 3 area box. I'm going to have x minus 3 as the side length on the left, and then on the top, x squared, 3x, and 9. And then I multiply everything together. So I have x times x squared is x cubed, x times 3x is 3x squared, x times 9 is 9x, negative 3 times x squared is negative 3x squared, negative 3 times 3x is negative 9x, and then negative 3 times 9 is negative 27. And then I'm going to collect all my like terms and simplify. Well, I'm going to add all of this up and simplify. I'm going to start with the highest power. So I'm starting with that x cubed. I only have one x cubed term, so I don't need to combine it with anything. I just have x cubed as my highest power. Then I'm going to look at the x squared terms. So I have negative 3x squared plus 3x squared. Those cancel each other out. They equal 0. So I don't need to write an x squared term. I have 0 x squareds. Then I go over to my x terms. I have negative 9x plus 9x. Those two cancel out as well. They equal 0 when I add them together. So I'm just left with x cubed minus 27 is my answer. I want you to do these two examples on your own, and then so pause this video and unpause it when you finish to check your answer. So these are the answers you should have gotten. If you did something wrong, make sure you fix it. And now we're going to talk about the patterns we see between these three examples. First thing that really stands out to me is that the x squared and x terms cancel out in each one of these examples. So the x squared and x terms cancel out when foiling. They're going to equal 0 when I add them together. Another thing that I notice is that I end up with 2 terms in the standard form in the answer. My answer is 2 terms, and there's subtraction in between. So that's the same about about all 3 of these. I end up with 2 terms and subtraction in between. When I've seen 2 terms and subtraction in between before, I saw the difference of 2 squares. Well, in these examples, I see x cubed in all of these 3 examples. Then maybe my second term is also something cubed. Well, can I think of a number that I can multiply by itself 3 times to get 27? Yes, I can. I can cube 3, and that would give me 27. What about 64? Well, 4 cubed is 64, and 125 is 5 cubed. So what I really have here is the difference of 2 cubes. Instead of the difference of 2 squares, I have the difference of 2 cubes. And that's really important to note here. The difference of 2 cubes is my answer. Another thing that stands out to me is that if I look at the constant in the factored form, it is what I cube to get that second term in my standard form. So the constant in standard form is the constant in the binomial in factored form cubed. Now that I've found the patterns between these three examples, I want to try to derive a formula for the difference of two cubes. So if I have a cubed minus b cubed, what is that going to be equal to every time? I'm going to look at these three examples again, and I'm going to compare my standard form to my factored form in each. Well, like I said, I have the difference of two cubes here for each of these examples. In the first example, I have x cubed minus 3 cubed. In the second example, I have x cubed minus 4 cubed. And then in the third example, I have x cubed minus 5 cubed. And what I want to do is I want to treat the first term that's cubed as a. So I want x to be equal to a. And I want to treat the second term as b. So I want 3 to be b in this example, in that example. For the second one, I want x to equal a and 4 to equal b. And in the third example, I want x to equal a and 5 to equal b. And then I'm going to replace everywhere I see 3 in this example, I'm going to replace it with b. And everywhere I see an x, I'm going to replace it with a. So I'm going to replace x is equal to a. So I see an a here, I see an a squared here, and I see an a here. Then if I do substitute the 3's for b, I see a b here, and I see a b here. I don't see a b here, but I'm going to look for a pattern to finish that, to label what that 9 actually is in terms of a and b. I'm going to look at my second example. So I have x is equal to a, and everywhere I see an x in the factored form, I'm going to replace it with a. So I have an a here, an a squared here, an a here. And then everywhere I see a 4, I'm going to change it to b. So I have a b here, and again, I don't know what that last term is. But if I compare the two examples, this 9 and this 16, well, 9 is b squared, and 16 is also b squared in that example. They're both, so for the first example, it's 3 squared, and for the second example, it's 4 squared. And if I look at the third example, I also see this number here is b squared. So it's 5 squared. And if I fill in the last example, replacing x is equal to a, so a squared, a, and b is 5, so b and b, I see that all of these are the same. A minus b times a squared plus ba plus b squared. A minus b times a squared plus b squared, ba plus b squared. A minus b times a squared plus ba plus b squared. So the formula for the difference of two cubes is a minus b times a squared plus ba plus b squared. The examples we just looked at were the difference of two cubes. Now I want to look at these three examples, which are the sum of two cubes. I'm going to try to factor these things based on the constants that I see in them. What are possible factors I want to think about? So for the first one here, x cubed plus 27, I want to think about what's a possible factor of this expression given the constant 27. So possible factors of x cubed plus 27 based on the 27 are, or let me just think about 27. Possible factors of 27 are 3 and 9. So it makes sense that probably, maybe, x plus 3 and x plus 9, maybe those are factors of x cubed plus 27. The way I can check if something is a factor is by trying long division with it. And if I get a remainder of 0, I know the thing is a factor. So I'm going to try x plus 3 first, since it's smaller and more likely to go into that thing. Inside of the long division bars, I'm going to put x cubed plus 27. But I want to include every term so that I can line everything up and I don't get confused. So I'm going to include an x squared term by putting 0x squared, and I'm going to include an x term by putting 0x, and then I have that plus 27. Now I've included all my powers down to my constant. inside, just like I do with synthetic division. I want to do that with long division too, if I'm missing a piece. Then I'm going to ask myself, what do I have to multiply x by to get x cubed? And that's x squared. I have x times x squared gives me x cubed. I have 3a times x squared is 3x squared. I know I am subtracting this because that is whatever I get after I subtract is what I have left over to take care of. So I have 0x squared minus 3x squared, which is negative 3x squared. I bring down that 0x and I start over. So x times x times what gives me negative 3x squared? And that's negative 3x. So I multiply x times negative 3x to get negative 3x squared, 3 times negative 3x to get negative 9x, and then I'm subtracting this expression to see what I have left over to take care of. And when I subtract, I get 0x plus 9x, which is 9x, and I bring down that last 27. I'm going to ask myself, what do I have to multiply x by to get 9x? And that is 9. I multiply 9 times x to get 9x, 9 times 3 to get 27, and I am subtracting this to see what I have left over, and I have a remainder of 0, which means x plus 3 is a factor, which means x plus 3 times x squared minus 3x plus 9 gives me x cubed plus 27. So I'm going to write x cubed plus 27 is equal to x plus 3 times x squared minus 3x plus 9. This looks very similar to the example we just did with x cubed minus 27. I have what I see here, I have a minus, I have a binomial times a trinomial, and I have that also down here. Binomial times a trinomial. The only difference I see in the binomial, I have x and 3, but there's subtraction here, whereas there's addition here. The only difference I see in my trinomial is that there was originally addition here, and now there is subtraction there, but everything else is the same. Only those two signs are changing. Well, let's see if that pattern holds true for the next example. So what are possible factors of 64? Or what factor makes the most sense? Since x plus 3 worked, and 3 is what I have to cube to get 27, then probably x plus 4 works for this example. So let's try x plus 4. But let's do this with synthetic division. So I have this x cubed. I want to do x cubed, x squared, x down to my constant. So I have the coefficient for x cubed is 1, coefficient for x squared is 0, x is 0, and the constant is 64. And on the outside, I'm going to put when this thing is equal to 0, what x value. And that is for negative 4, so negative 4 goes on the outside. I bring down the 1. Negative 4 times 1 is negative 4. Add these together, I get negative 4. Negative 4 times negative 4 is 16. Add these together, I get 16. Negative 4 times 16 is negative 64, and I get 0 as my remainder. Well, that means that x plus 4 is a factor. So I know that x cubed plus 64 breaks down into x plus 4 times my answer here. Sorry, I forgot to do it. This is my remainder, this is my constant, this is the coefficient for x, and this is the coefficient for x squared. So I have x squared minus 4x plus 16 is my answer, and that's what I multiply by x plus 4 to get x cubed plus 64. Let's look at when I had x cubed minus 64. So when I had x cubed minus 64, I had my binomial times my trinomial, same thing as I have down at the for x cubed plus 64, except I have, the only difference is the terms are the same in both, except I have a subtraction sign in the binomial for x cubed minus 64, and I have addition in the binomial with x cubed plus 64. The other difference is that I have addition in the trinomial there between the x squared and the x terms, and here I have subtraction. So for this last example, without finding the possible factors, I think it's safe to say that I'd have x cubed plus 125 broke down into, instead of x minus 5 here, I'm going to have x plus 5, and instead of x squared plus 5x plus 25, I'm going to have x squared minus 5x plus 25. So what patterns do I see in these three examples? I just kind of went through them. I see that I have the sum of two cubes. I forgot if this was a question. So I have the sum of two cubes instead of the difference of two cubes. I have the factors are a binomial times a trinomial. And I see that the cubed root of the constant in standard form is equal to the constant in the binomial in factored form. Okay, and then if I wanted to derive a formula for x cubed plus b cubed, I would see I have a plus b times a squared minus ba plus b squared. And now I just want to put those two together, the difference of two cubes and the sum of two cubes. The formula for x cubed minus b cubed is a minus b times a squared plus ba plus b squared. And the formula for the sum of two cubes is a plus b times a squared minus ba plus b squared. And I'm just going to highlight what's important here. If I have subtraction, I have subtraction in the binomial. If I have addition, I have addition in the binomial. If I have subtraction, I have addition here between the x, so between my a squared and my ba. And if I have addition, I have the opposite, subtraction in between the two. And those are the two formulas you need to know when you see the difference of two cubes or the sum of two cubes. I'm going to practice using them. So let's use the formula for this first example, 27x cubed plus 1. First thing I want to do is break this down into what is actually being cubed to get 27x cubed. And what's actually being cubed is 3x. I'm raising 3x to the third power. What's actually being cubed to get 1? I know that it's going to be 1 to the third power. So now I know what my a and my b are. I'm going to highlight. So I have my a is 3x and my b is 1. So, oops, let me write that. A is equal to 3x and b is equal to 1. And then I'm going to plug them into my formula. So this is the sum of two cubes. I'm going to use the sum of two cubes formula. So a plus b times a squared minus ba plus b squared. And then everywhere I see a, I'm replacing it with 3x. So this is 3x squared. Make sure you're multiplying, or you're raising both 3 and x to the second power. I have a 3x here, and I'm going to put that in parentheses since I'm going to be multiplying it by b. I'm going to now replace b with 1. Everywhere I see a b, I'm replacing it with 1. So 1 squared. And then I'm filling in what are my operations. So I have 3x plus 1 times 3x squared minus 1 times 3x plus 1 squared. And now I just simplify. So first term I'm going to have is 3x plus 1. Second term is I got to distribute that exponent of 2. So I have 9x squared minus 3x plus 1. And this is my answer. Right, for the second example, I want to break this down into what's actually being cubed here. This is the difference of two cubes. What is actually being cubed here? And that is 5x. So I'm raising 5x to the third power to get 125x cubed. For the second term, I know that we've done this several times already. It's 4 cubed. So I have the difference of two cubes there. So I'm going to use the difference of two cubes formula, which is a minus b times a squared plus ba plus b squared. And first thing I'm going to do, I'm going to highlight what's my a, what's my b. My a is 5x, my b is 4. I'm going to just label that. So a is equal to 5x, b is equal to 4. And then everywhere I see an a, I'm going to replace it with 5x. And everywhere I see a b, I'm replacing it with 4. So a replacing with 5x. This is 5x squared This is 5x. I'm going to put it in parentheses because I'm going to be multiplying by that b. I'm replacing every b I see with 4. So 4, 4, and this is 4 squared. And then I'm plugging in everything else I have. So I'm putting in my operations, and then I'm simplifying. So I have the answer is 5x minus 4 times 5x squared is going to be 25x squared. I have 20x and 16, and this is my answer. All right. The next thing we're going to talk about is grouping. We just talked about when we had two terms, so the difference of two cubes or the sum of two cubes. For grouping, you're going to use that when you have four terms. For the other ones, that was you were going to use for two terms. So 4 terms, you're going to use grouping. You're going to group into pairs, and then you're going to find similarities between the two pairs. So I'm going to just do an example. Looking at this group of 4 terms together, I'm going to separate it into 3x cubed plus 9x squared. That's one group. And the second group is going to be 4x plus 12. I'm going to look for similarities between the two. So similarities between the two groups. Well, one thing that I see in common is that the power difference is the same. So if I look at x cubed and x squared, that's 1 power away. And if I look at x, and this is technically x to the 0th power, so that's x to the first power and x to the 0th power, those x's are 1 away from each other as well. So what I can say is the x powers are 1 away from each other. So I have x cubed and x squared, and x to the first power and x to the 0th power. Another thing that I notice is looking at the coefficients, so 3 compares to 9, as 4 compares to 12, or looking at the numbers, because 12 is constant, the first number is 1/3 of the second number. So the first coefficient is 1/3 of the second coefficient. So that's another similarity that I see. This is technically a coefficient because it's for x to the 0th power, a coefficient for that. All right. Now, what I want to do, based on the similarities I just saw, is I'm going to take out the greatest common factor of both groups and see if I see a pattern. I have, what do these two terms have in common? Well, they have a 3 in common, and they have an x squared in common. So if I take out 3x squared, I'm going to end up with 3x squared times x plus 3. And then in the second group, if I take out the greatest common factor, that's 4, and I'll end up with 4 times x plus 3. Well, what I see in common is that I have x plus 3 here and x plus 3 here. That 3 comes from the 1/3 thing I was talking about, and the x term comes from the powers being 1 away from each other. And so what I can do here is, this is like saying I have 3x squared of x plus 3 plus 4 of x plus 3. It's like if I had 5x plus 3x. What would I do to find the answer? I know the answer is 8x, right? I know it's 8x. Well, what I actually do is I take the coefficients of the x's, so I have 5 plus 3, and then I multiply that by x. And I know I have 8x. So in this example, what I'm going to do is same thing. So I took 5 and 3, and I added those together. Well, here, I'm going to take the coefficients of x plus 3, which is 3x squared and 4, and I'm going to add those together. So I have 3x squared plus 4 times x plus 3. And that's my answer. And then if I do this example here, I'm going to group it again. I have, this is the first group, this is the second group. I'm going to see that the similarities are very similar to the ones that I had in the first example. The x powers are 1 away from each other. And the first coefficient, but in this example, the first coefficient is 1/5 of the second. If I take out the greatest common factor, I'm going to see a pattern again. So I'm going to take out the greatest common factor of the first group, and that's 2x squared. So I get 2x squared times x plus 5. And in the second group, if I take out the greatest common factor, I have a negative 3 times x plus 5. And that will give me, when I combine these, I know I have 2x squared of x plus 5 and negative 3 of x plus 5. So I have a total of 2x squared minus 3 of x plus 5. That's how many x plus 5s I have. And this is my answer. That's factored form. And for the last example, I have this group and this group. What I notice is the same about them is they both have the same coefficients, 4 and 7, and their powers are, again, 1 away from each other. If I take out the greatest common factor, I'm going to see a pattern again. So the greatest common factor in the first one is x cubed. So I have x cubed times 4x plus 7. And the second one, I'm just going to leave it as 4x plus 7. It doesn't have a greatest common factor. But I am going to write it as 1 times 4x plus 7 to put that 4x plus 7 in parentheses and see what am I multiplying it by. Because now I can see that I have 1 4x plus 7 plus x cubed of 4x plus 7. So I have a total of x cubed plus 1 4x plus 7s. And so my answer is x cubed plus 1 times 4x plus 7. The other type of factoring we're going to see is when we see 3 terms. So when you see 3 terms, it's most likely going to be what we're about to do. I want to know what do these 2 examples look similar to? What do they look similar to? And you should see that they look similar to ax squared plus bx plus c form, except here x is actually x squared. So that x term that I usually have in the middle is x squared instead. What I would normally do to factor this 3-term expression is I would use the diamond. I would look for 2 numbers that multiply to 4 and add up to negative 5. So multiply to that constant and add up to the coefficient before the x. And those 2 numbers in this example would be negative 4 and negative 1. So this would normally break down into x minus 4 times x minus 1. But in this case, I actually have x squared instead of x. So everywhere I see an x, I'm going to replace it with x squared. So I have x squared minus 4 times x squared minus 1. And if I FOILed that, I would get this thing. I can factor this a little bit further to be x plus 2 times x minus 2, since x squared minus 4 is the difference of 2 squares. And then the second thing, x squared minus 1, also breaks down into x plus 1 times x minus 1, and this is my final answer. For the second example I have here, this looks like ax squared plus bx plus c form, where a is equal to 1. So I could use the diamond to go straight to factored form. I'm looking for 2 numbers that multiply to negative 24 and add up to 2. So I was looking for them to multiply to the constant and add up to the coefficient of what would be my x term. And then I'm going to see that that is positive 6 and negative 4. So this would break down into x plus 6 times x minus 4, except instead of x here, I have x squared. So everywhere I see an x in my answer, I'm going to put x squared instead. And then I'm going to simplify further if I can. So what I have is x squared plus 6. Can't break that down further, but I can break down x squared minus 4 further into x plus 2 times x minus 2, since it's the difference of 2 squares. And this is my answer. All right, and then the last thing I want to talk about in this video, we should also be able to write the equation of a polynomial function given its roots or its zeros or its x-intercepts. So if I want to find a polynomial function of the 3rd degree, so important, note what it says there. It says 3rd degree, so it has to be x cubed, my answer. In standard form, that has zeros 0, 5, and negative 7. So for the 0, 0, or the x-intercept is 0, that factor would be x minus 0, or just x. For the 0, 5, the factor would be x minus 5. And for negative 7, the factor would be x minus negative 7 or x plus 7. These are my three factors that I'm going to multiply together. So I'm going to multiply x times x minus 5 times x plus 7, and that's going to give me my answer. I'm going to do x, I'm going to distribute that x to the x minus 5 first, which will give me x squared minus 5. Or I should just do this in black. Which will give me x squared minus 5x. And I'm multiplying that by x plus 7. So I'm going to multiply everything in the left parentheses by everything in the right parentheses. I have x squared times x, which gives me x cubed. X squared times 7 is 7x squared. I have negative 5x times x gives me negative 5x squared. And negative 5x times 7 is negative 35x. And then my final answer is going to be, when I collect my like terms, x cubed plus 2x squared minus 35x. And that's my answer in standard form, which is perfect because I needed it to be third degree, and it is. So that's its highest power. For the next example, find a polynomial function of the fourth degree that has roots plus and minus 1 and plus and minus 5. So what I actually have here, the factors that I have from here are x minus 1 and x plus 1. And then the factors I have from there are x minus 5 times x plus 5. And I know this is going to give me the difference of two squares, and this is going to give me the difference of 2 squares. So I'm going to have x squared minus 1 squared, which is 1. And this is going to be x squared minus 5 squared, which is x squared minus 25. And then I multiply those together. So I have x squared times x squared is x to the fourth power. X squared times negative 25 is negative 25x squared. I have negative 1 times x squared is negative x squared. And then negative 1 times negative 25 is plus 25. And my final answer is x to the fourth power minus 26x squared plus 25. And this is my final answer, and it makes sense because it's fourth degree like it was supposed to be. So I'm good. All right, and then the last one is I want to find a polynomial function of fourth degree that has these x-intercepts. So I have an x-intercept I have x minus 2, x plus 3, and x plus 4. The problem is when I multiply these three together, I can already see I'm only going to get the third degree. I'm only going to get a third degree polynomial. So I need to add another factor here. But these are the only x-intercepts, so I need to pick one of those three to add. And I'm going to pick the smallest one because I like to deal with smaller numbers. So I'm going to multiply by another x minus 2. X minus 2 times x minus 2 is going to give me x squared minus 4x plus 4. X plus 3 times x plus 4 will give me, wait, did I mess this up? No, I didn't. X plus 3 times x plus 4 is x squared plus 7x plus 12. And then I multiply all of this together, and I'm going to use the area box to do this. So it's a lot of terms to keep track of. So I have x squared minus 4x plus 4 and x squared plus 7x plus 12. This is going to be x to the fourth power, 7x cubed, 12x squared. This is negative 4x cubed, negative 28x squared. This is negative 48x. I have 4x squared, 28x, and 48. And then I add all of these things together. Starting with my highest power, I have x to the fourth power. The next thing I have is my x cubes, which is going to give me 3x cubed when I combine them. Then I add my x squared terms, negative 24x squared plus 12x squared is going to be negative 12x squared. And then I combine my x terms to get negative 48 plus 28 is negative 20. x, and then I have my constant at the end, which is 48. So this is my answer.